and welcome to CCTech online training. In this training I am going to explain you one aspect of CFD, which is nothing but pre-processing. As CFD is known as a three-step process in which there will be a pre-processing where we create the geometry and mesh the geometry. There will be a solution where we will solve the governing equations by using finite volume method, and the third process will be the post processing where we'll visualize the data. So in this lecture I am going to focus on the first aspect of CFD, which is nothing but pre-processing, and I am going to introduce you one pre-processing tool which is available, which is nothing but Gambit, which is from ANSYS Fluent. And in fact in this lecture we are going to have a look at the GUI of Gambit, how to work with GUI of Gambit, what are the mouse operations and where the buttons are located. So let's start. So Gambit is Geometry and Mesh Building Intelligent Toolkit. It is a single integrated preprocessor for CFD analysis. What do I mean by single integrated preprocessor? In the sense, you can create the geometry, which is the first step in CFD analysis, creating the fluid domain or a solid domain for heat transfer analysis. So you can create the geometry in Gambit. There are two ways in fact for creating a geometry in Gambit. The second step is you can mesh the geometry. It means you can divide the domain into small parts using simple shapes like tetrahedra, hexahedra if it is 3D, or if it is 2D it is triangle or quadrilateral. Once the mesh is created, we can apply boundary conditions as per our requirements, and we can export that mesh for our simulation. So there are two ways of, as I said, creating geometry in Gambit. One is Gambit has provided the geometry modeling capabilities, like you can create moderately complex geometries in Gambit, but the geometry modeling capabilities in fact are not that great as we have seen in any standard CAD software. So we can use Gambit for creating simple geometries, but if the geometries are complex, like if you are talking about a flow or a car where the surface geometry of the car is very complicated, using Gambit will take a lot of time to create those kind of geometries. But what we can do is, in that case we can use a standard CAD software like Pro-E, CATIA, SolidWorks or something, and once the geometry is created in those CAD softwares, we can export that geometry into a standard file formats which will be acceptable by Gambit. So those standard file formats like are STEP, Parasolid and IGS. I will talk about the import capabilities and what are the issues for different file formats in another lecture. So the another you can say method of taking geometry into Gambit is you use a standard CAD software, you export that particular CAD model into a standard file formats which are STEP, Parasolid or IGS, and then you use Gambit import capability to take that geometry into Gambit. Once the geometry is there in the Gambit, then because of the import issues and all, because of the data loss and all, we have to repair the geometry. And then once the geometry is repaired, it means once we have created the watertight volume, then it is ready for meshing. Once the geometry is ready, we can create structured or unstructured mesh by using Gambit. There are in fact very good meshing capabilities available in Gambit. So don't get confused with the structured mesh in Gambit and structured mesh in ICM CFD. They have a different philosophy. In fact in ICM CFD we use something called as multi-block structured mesh functionality, where we will use blocking and all the stuff. But in Gambit we can have structured mesh, you can say by using schemes like map or submap. We'll have a look at the meshing schemes, structured meshing schemes in Gambit. So once the geometry is finalized, we can divide the geometry by using different meshing capabilities available, and the type of the elements typically created in Gambit. If you talk about 3D model, the type of the mesh or the type of the cells which will be created will be hexahedral, tetrahedral, pyramids and prisms. All these type of shapes are in fact supported by Fluent Solver. Once the mesh is created, we have to examine the mesh. It means we have to check the quality of the mesh so that our solution will be good. So in fact there are different quality criteria available in Gambit. We'll talk about it later. Once the quality is good, if we are happy with the mesh, then we have to apply or we have to create the zones for applying boundary conditions. because those zones will be visible in Fluent, and it will be easy for creating a setup, solution setup. So the last stage that you do in Gambit is apply the boundary zones. Once everything is ready, we can take that mesh to different solvers, and one of them is Fluent. So this is the general sequence of operation in Gambit. This is the initial step where you will select the solver. It means for which type of solver, which solver you are creating mesh. For example, are you creating a mesh for Fluent, are you creating a mesh for feed app or something like that. We have to select the solver, because based on the solver the type of elements will be selected. Once that is done, we have to also decide about what is the mesh size that we should have in the geometry, what is the type of clustering we should have in the geometry. Like, this is nothing but doing pre-processing. It means before starting the model itself, we should understand the problem, and we should understand what type of mesh that we should look for. And in Gambit there are something called as defaults, which are very strong. So those defaults will determine how your geometry will behave. The defaults will determine how your meshing will behave. We'll have a look at defaults later. Once the initial setup is done, once you have decided about all these factors, then you have to create the geometry. As I said, you can use geometry capabilities available in Gambit, or you can use the import facility available in Gambit. So create the full geometry, and the next step, which most of the time which we'll do, because most of the time we'll be interested in hexahedral mesh in the volume. So what we do, we divide the geometry in such a way that whatever the meshing capabilities or whatever the meshing algorithms available, like map, submap or Cooper, will decompose the geometry in such a way that those kind of meshing schemes will be successful. So the second step that we do after finalizing the geometry is decompose the geometry in meshable sections. Once that is done, we go for meshing. There are two meshing strategies generally used. One is called as local meshing, another is called as global meshing, or in other way, one is called as bottom to top meshing, and other is called as top to bottom meshing, in fact. So what we do in bottom to top meshing is we start with the lowest order entity. In this case it will be a edge, if you talk about meshing. So we do a edge meshing, and then we go for a face meshing, and then we go for a volume meshing, so that we can have a better control on the mesh. But you can always directly go for volume meshing, where you define that, okay, this is the size of the mesh that I want in a volume. So what it will do, what Gambit will do is, it will also mesh the lower order entities like face and edge with the same size that you have specified for a volume mesh, and in fact in this case we will not get a better control on the mesh. Once the mesh is done, the next step that you do, as I said, is examine the mesh, check whether the mesh is proper or not, check whether quality of the mesh is proper or not. Once that is done, assign the zone like continuum and boundary attachment. Continuum is nothing but in which region you will treat as a solid and which region will treat as a fluid. Like if you are interested in conjugate heat transfer, for example, like heat exchanger problems, and if you are modeling the thickness of the pipe, in that case we have to also model a solid domain. So we have to define which one is solid and which one is fluid, and along with that we have to also specify which one is inlet and which one is outlet, or which one will act as a wall, or which one will act as an interior, which we have used only for decomposition of the geometry and all. So that is nothing but zone assignment. Once that is done, we have to export the mesh, and typically that is the like you will be exporting a mesh for Fluent or CFX or something like that. The purpose of this particular presentation is to describe the general form of Gambit startup command, the organizational structure of the files, in the sense what kind of directories that Gambit will create, and the GUI of Gambit. So this is the typical icon that you see on the desktop. Once the Gambit is installed successfully, you will see this kind of icon, this kind of typical icon. So this is the icon that you will see. If you double click on this icon, then this particular window will be opened. This particular window will be opened, and in this window we have to specify particular things like what will be your working directory, what is your session ID, and what are the options that you are going to use. The working directory is nothing but where Gambit will store the files. Gambit creates some temporary files, which I will talk about it later. So you have to select which is your working directory. Session ID is like a project name. For example, if I am using a MS Office, let's say Word, MS Word, then you provide some name to the file. So this session ID is same as the name to the file, but this name is common for all the files which will be there. There are 3 files which are associated with Gambit, and these options are nothing but if you are interested in running Gambit with some options which I will talk about it, then you have to give this option somewhere here, and once you say run, Gambit will open. Now these are the options, these are the typical options which are available in Gambit. The most important option is like generally which will be needed if you want to do this automatic processes. For example, INIT, this is nothing but this particular option will read in the journal file. Journal file is nothing but a command file for Gambit, and it will do all the process automatically by reading the commands in the journal file. It will do the process automatically. So this is one of the option for Gambit. So if I want to do this, then in that option form, in the option for option here, I have to specify that -init and what is the journal file name. Right. I will talk about the journal file use and what do I mean by automatic process and all later. So these are some of the options. These are the typical files or directories which are associated with Gambit. One we call it as a home directory, other is called as source directory. There is something called a scratch directory and working directory. You need not to worry about all these directories. The one thing that you have to worry about is the working directory and how it works and what is the use of the working directory. It means whenever I start Gambit, what Gambit does is Gambit creates one temporary directory where there will be files which will be saved automatically. It means if something goes wrong, or if Gambit is crashing, or let's say there is a power off or something like that, what you can do is you can actually retrieve back what you have done. I mean, you will not lose the data. So what Gambit does is in working directory, Gambit puts the temporary files, 3 files are there in fact, which is dbs, jou and trn. It puts those temporary files in the working directory. Whenever user specifies a command like save, let's say I want to save the files, then what it does is whatever the files which are there in a working directory, which is a temporary directory, it copies that file into a parent directory, which we call it as a home directory. So working directory is a subdirectory of a home directory. For example, let me start Gambit. For example, this is the GUI of Gambit, and I have started. My working directory is, I guess, let me see what is my working directory. Okay, fine, let's start Gambit once more. This is, as I said, this is the Gambit's icon. If you see, this is the working directory which I am selecting. Let's say document and setting administrator. This is my working directory. I'll say run. Now if you go to this particular directory, document and setting and administrator, that is actually my home directory. So let's go to this particular directory. So C drive, document and settings, administrator. If you see, this is my working directory and it has created one, this is my home directory in fact, and it has created one working directory. The working directory name is always Gambit something, so I'll talk about it later. So this is the name of the working directory. In a home directory there will be a working directory which is a temporary directory whose name always starts with Gambit. So if you go to this particular directory, you will see that there are different names. For example, this name, this starts with Gambit. Let me see which is my working, yeah, I guess this is my working directory. So the name of the working directory is Gambit dot some number is there, and this number is nothing but the process ID of the process. I mean, whenever you start a Gambit, Gambit is nothing but one process. So this is nothing but the number of process ID of that particular process. In that directory, if you see, there are 3 files. One is default ID 2424.dbs. GOU and TRN. These are the three files which are associated with Gambit. So once I execute a command, let's say save file, save, now you will notice that all these three files are copied into a home directory. If you see default ID 2424, and these are permanently available on your hard disk. Now if I exit Gambit, for example, if I exit Gambit, now if you notice, what happens is it deletes that working directory. It means it automatically deletes the working directory. Working directory in fact is a temporary directory. It means it is not a permanent directory. Whenever you exit Gambit successfully, it deletes the working directory. Now if you have not executed a command called as save, then what will happen? The files which are there in the working directory, they will be also deleted. So before exiting Gambit, you have to save the file so that the files will be copied permanently in the home directory. So this is about, don't get confused with this working directory and home directory. Just remember that there is one directory called as working directory whose name will be gambit dot something, and in that it will automatically store the files. Whenever you execute a command save, it will permanently store the files into your parent directory. That is what the concept is. Along with that, you have to also worry about one file which is there, which is nothing but a log file. So what log file does is, let's say I will start again Gambit. I will start Gambit. If we go here, you see it has created one working directory which is Gambit 3028. It has created a working directory which is Gambit 3028, and along with that, if you see here, it has created one log file which is nothing but default ID 3072 log. So default ID is nothing but the session ID of this number, default ID 3072, and it has created a log. What the use of this log file is, Gambit will not allow any other user to open same file at the same time. Same file in the sense that file has to be on the same computer, that is the first thing. The file has to be in the same directory, that is the second thing. And it has to be, the file need to be accessed at the same time. That is nothing but the conflict. We call it as a conflict. So what Gambit does is, through this log file, it will not allow user to open the same file at same time. It means it will not allow two users to do changes on the same file at the same time. So whenever this log file is there, it will always create this. Whenever you open a Gambit, it will always create this log file, and this log file will actually prevent a user to open a file. Sometimes this is useful and sometimes it is problematic. Let's say I have saved this file. For example, I will say this file save as I'll say something like, let's say I want to do a pipe simulation, so file save as pipe. I saved this file. So if you go here, there is something called as pipe.gou, pipe.trn and pipe.log. Now if something happens wrong, what will happen? This log file will be there. This log file will not be deleted, it will be always there. Now let's say Gambit is terminating, there is a power off or something. What will happen? This log file will be always there. Next time I cannot open this DBS file because there is a log file. It means Gambit will understand that somebody has already opened it, which is not the case. It is understanding it because there is a log file. So what we have to do is, we have to delete this log file, and then only we can open this DBS. So this is another case where we need to be careful about deleting the log file. But if you are exiting Gambit normally, for example, if I exit Gambit, then if you see, automatically this log file will be removed. That log file is removed, again that temporary directory is removed. So that is the concept. So these are the the directory. This is something about the directory and the log file. Fine. So now there are three files which are associated with Gambit. Every software in fact has some files associated with that. For MS Word, if you remember, the file which is associated with the doc file. If you talk about Notepad, the Notepad file associated is a text file, txt file. So similarly, for a Gambit, there are some files associated with that. There are typical file formats, and there is a typical data stored in those files. So there are three files. One is DBS file, which is nothing but a database file. In database file, everything will be stored, in the sense the geometry will be stored, all the geometrical information will be stored, all the mesh information will be stored in DBS file, all boundary condition information will be stored in DBS file. So everything is there in a DBS file. So if you have only DBS file, that will be also sufficient to start your new session, in the sense to work on that particular geometry. Another two files which are there, which are very useful. The another file is a JOU file, which we call it as a journal file. In journal file, what Gambit does, it stores all the commands which have executed by a user. It means if I am creating a model, let's say I have created a cube, I want to create a cube. Now you can create a cube by using Gambit GUI. Now whenever I create a cube, internally what Gambit does is Gambit executes one command. So that command will be actually stored in that particular JOU file, and next time if I want to create a same cube, then what I can do is, rather than using GUI, I can go to journal file, copy that command, and then paste a command and execute the command. That is what I can do. So that is the use of journal file. In fact, it's a very strong functionality available in Gambit. So in journal file, what is stored in journal file, all the commands which are executed by Gambit will be stored in a journal file. In TRN file, there is something called as transcript window, which I will introduce you when we'll have a look at the Gambit GUI. In transcript file, all the things which are displayed by Gambit, it will display all the messages related to, okay, volume is created, mesh is created, these many elements are there and all. That will be displayed in a transcript window. And what Gambit does is, Gambit stores all this automatically in one file called as TRN file. So if you want to have, I mean, let's say you have done, you are going for a direct volume meshing, and you have defined some size, and let's say volume meshing is failing. So what we have to do is, it might be failing because there is one phase which is not meshed successfully. So what we can do, we can go and open a TRN file, and we can have a look at what is the name of the phase which is not meshed, so that we can go back and have a look at that phase independently and define some different meshing criteria or meshing strategies for the same. So the use of TRN file is to know what Gambit is doing, what are the messages which are displayed by Gambit. That is the use of TRN file. So there are three files associated with Gambit. This is about, if you are going to copy the files from one location to another location, what happens. So I hope that you are clear about the working directory and the files associated with Gambit. Now let's have a look at the GUI of Gambit. In fact, we'll see in detail the journal file, because that is the most important file, I believe, in Gambit, where we can use it for automatic grid generation and geometry, or parametric modeling, in fact. So let's have a look at the GUI of Gambit. So this is the typical, you can say, GUI of Gambit. There is something called as a menu bar here. There is something called as menu bar here. This is menu bar. Then in the menu bar there will be file, edit, solver, which we'll have a look at it. There is something called as a graphics window. If you see this is called as a graphics window. There is something called as operation toolpad. In graphics window, definitely, I mean, what will happen is, whatever you want to display, like you want to display let's say a model or the mesh or the quality of the mesh, that will be displayed in the graphics window. This is called as operation toolpad. In operation toolpad, there are different operations that we can do, and they are also arranged sequentially, the way we'll be executing project in Gambit. Like the first one is create geometry, the second one is create mesh, the third one is apply boundary condition, and these are nothing but separate tools. If you want to use some advanced tools, you can use it. So this is called as operation toolpad. This is called as the global control toolpad. What it will do is, it will control the way the model is displayed in the graphics window. That is what it will control. So this is called as global control toolpad. This is the description window, and this is the most important window if you are a beginner in Gambit. So this description window will tell you the description of each and every button. If you point your button, or if you point mouse on a particular button, it will display what is the function of that button. This is what I was talking about, this transcript window, in which Gambit will display all the messages, like what it is doing and what is going wrong and all. Now this is called as a command prompt. I guess if somebody has used AutoCAD or any other CAD software, most of them have a command prompt. So this is the command prompt of Gambit. It means whatever I do here, let's say I am creating a cube, I can always create a cube by typing a command which will create a cube here. So this is called as a command prompt of Gambit. Now let's have a look at Gambit. So as I said, this is the GUI of Gambit. This is called as a menu bar. In that there is a file menu, in that there is a edit menu, in that there is a solver menu. This is called as a graphics window. The use of the graphics window is to display the model, the way the model will be displayed, or to display the mesh and all. This is called as a graphics window. This is called as operation toolpad, which will expand. If you click on it, it will expand. So this is called as a geometry tool. This is called as a meshing tool. This is called as boundary condition or zone assignment tool, and these are the different tools which are available. So in geometry, if you click on, again in geometry, it will expand, and it will show you different entities, how to create different entities, like there is a vertex creation, edge creation, face creation, and volume creation, and in fact there is something called as group creation also. Now again, if you go to meshing, there is something called as edge mesh, there is something called as face mesh, there is something called as volume mesh. So this is the way it will work. If you click on it, it will expand. And as I was talking about, if you are a beginner of Gambit, now you just point your mouse somewhere on the button. Let's say this is the geometry button, and if you have a look at this, it will display that what this button does. For example, right now it is displaying geometry command button opens toolpad that allows you to create and modify the model. If I click here, and if I, let's say I am pointing my mouse on the vertex, it says vertex command button opens a subpad related to operations involving vertices, something like that. So if you are a beginner, then this description window will help you out to know what exactly that button does. In fact, right now it is showing me description window displays the message describing it. It gives the description about itself. Fine. So this is the global control toolpad, which will decide how the model is displayed in the graphics window. For example, right now I can have a look at the front view, or I can have a look at the isometric view, or I can have a look at the shaded form of it, or I can have a look at what I can change the lightings and all, something like so. This is the global control toolpad. This is what the transcript window is, which will display what is the thing which is done by Gambit. So right now I can always expand this, which is something like this. Now if you see, it also says that volume create brick with 10. This is nothing but the command associated with creating brick. Now it will also display that created volume, volume.1. Volume.1 is the label of the volume. Then I have shaded, I have a wireframe and all. So this is nothing but Gambit, and this is the command prompt, as I said, of Gambit, where what I can do is I can type some command which is associated with creating some geometry and meshing some geometry, and actually I can create whatever the operation which are done by this GUI. So that is this is some brief about the Gambit GUI. Let's have a look at the components in detail. So the first is the graphics window. This is nothing but the graphics window. By default, the graphics window is divided into 4 quadrants, and by default the upper left corner will be displayed to you. What you can do is you can actually change your view into 4 quadrants. For example, there is something called as chassis. There will be a vertical and horizontal chassis. So if you click on this, the second line, if you remember, this is the second line. If you click on this and if you drag, your model will be like, this is nothing but the first quadrant, this is the first quadrant, this is the second quadrant. Again there is one horizontal chassis. If I click and drag somewhere, something like this, now this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. You can get taken in that way. Now I can always rescale it by just clicking on, this is called as chassis anchor. If I take this, you can actually have a look at this. This is nothing but the chassis and chassis, the use of the chassis anchor. Most of the time, if this is useful if user want to have a different views of the model at a time. That is why these things are designed. Now if you right click on this, Now there are certain configurations already available, the default configurations. It means, let's say I want to have a look at the upper left quadrant. If I click on that, there will be upper left quadrant. Or it means how I can activate that, just right click on that, keep on pressing the right click and go to the configuration that you want. For example, I want 4, so I'll say 4. So this is nothing but the default configurations which are available, which you can use. In fact, the one interesting thing is, like, let's say user is interested in having a look at the model in a particular way, which is not a standard way. So for example, if I want to have a look at the model in this way, if I want to have a look at the model in this way and this way, this is a particular way in which he is interested in. What I can do is I can actually store these views in registry. So if you see, there are 2 registries available. Again, if I right click on this, there is something called as 1 and 2. So what you do, you set your views in a particular way. Now right click on this session anchor and go and say set view 1. Now whatever I do, let's say I am doing something like this and this, and I want to go back to the view which I am interested in, then I can say 1. If you see, it is the same view that which we have started with. So this is the registry that you can put. And I mean, these are not very strong functionalities. In fact, I mean, don't waste time on knowing these things, but yes, they are there, which you can use, I mean, for your own comfort. So this is something about the graphics window. So this is what the graphics window says, that it has a quadrant, it has sachet, it has sachet anchor. Quadrants, there are 4 quadrants, 1, 2 or 4 can be displayed simultaneously. Each quadrant can be customized to create a distinct representation of the current model. Default graphics window configuration displays only the upper left quadrant, that is what I said. Each quadrant possesses a set of orientation axis. What do I mean by that? This is nothing but, this is the orientation axis, which will tell you what is the orientation of your model. If you see, there is also orientation axis, here also there is a orientation axis, here also there is a orientation axis. So this orientation axis will tell you what is the orientation of your model. It means if the model is very large, something like this, I really don't know what is the orientation of it. So what I can do, I can have a look at this. I guess this is something like isometric view, right? The orientation, these 3 quadrant or whatever the axis, this is not the origin, so don't get confused with that. This is actually the orientation of the model. Origin is somewhere here. Origin is something like this, which is nothing but this. This is the origin of the model. So don't get confused with the orientation and don't get confused with the origin of the model. So that is nothing but each quadrant possesses a set of orientation axis in its lower left quadrant, indicating the global orientation. Quadrants are separated by sachets, one horizontal, one vertical. Sachet appears thin gray line. There is nothing but this. There is nothing but a sachet which occurs as a thin gray line somewhere here. So these are the thin gray line. There is one vertical and there is one horizontal. Fine. By default, sachets are located at the bottom right side of the graphics window. To resize the dimension, left click and drag it, or something like that. I guess you know this. This is the sachet anchor, which you can click and you can resize the window into 4 windows at a time, something like that. So there are some default views you can set. So fine. So let's go to a file menu. What file menu does is, now I want to have only left, upper left quadrant. So if you go to file window, these are the standard things. If you go to any Windows software or anything, there is something called as new, which will open a new session. There is something called as open, which will open an existing session. There is something called as save, which will save the existing session with the name which you have provided, same name. If you say save as, it will allow you to save the session with some different name. Now there is something called as print graphics. What print graphics will do is, let's say you have created the geometry and you want to create the report. You want to put this view into your geometry. So what you can do, you can actually print it into a file. Different type of file formats are available, like TIFF is there, then PS is there, EPS is there, then TIFF is there, PS is there, EPS is there, and all. So TIFF is nothing but on Windows you can use that. So what it will do is, it will print the graphics into this particular file, and you can put it in a report. In fact, I don't use this. What I use, maybe a print screen, or maybe some free tools which are available, which are like MW Snap or something like that. I generally use that. But Gambit can also print the graphics, or it can also store the image into one particular file which you can put into a report. These are the two buttons, strong buttons, which are nothing but run journal and clean journal. As I said, journal file is nothing but a file in which the commands will be stored. So what you can do is you can actually use that file for doing the same thing that you have done previously. So what I can do is I can say run journal. I will browse that journal file in which the commands will be stored, and when I say accept, everything will be done automatically. I will give the explanation about this later. Journal file. In journal file, sometimes there is some junk data available, like if you do some undo redo commands, that will be also stored in the journal file. So we don't want, actually they are not executable commands or something. So what I can do is actually I can clean the journal. So if I go to clean journal, it will ask you what you want to remove. Remove the comments, remove the error commands, remove save commands, remove parameter commands and all. So I can clean the journal, and that clean journal I can use it for creating the same geometry or doing the same process. So this is about clean journal. View file is nothing but it will allow you to view the file. In fact, this is generally used for looking at the journal file. So I can browse a particular journal file and I can view that particular journal file. For example, this. So you see, this is the typical journal file. So I can view that typical journal file, and so this is to view the journal file. This is nothing but import. If you have created a CAD model into some other CAD software, you can actually import that CAD model into Gambit by using these type of file formats. So there is ANSYS support, Parasolid, IGS tape, direct support for CATIA v4.5, direct support for CATIA v5 files. Then ICM input is something like a formatted point data, something like that. Vertex data is, it means if you have stored the data, it means the coordinate of vertices into one particular text file, you can directly create 1000 vertices at the time, something like that. Mesh is nothing but you can import the mesh and all. So this is something about import. I will talk about it later. Export is nothing but you can also export the geometry which is created in Gambit for other purposes. For example, you can take it into other pre-processing tool like ICM, or the most important is like export mesh, which is this. Export mesh will allow you to export a mesh for Fluent. So that is what it will do. And reconnect CAD is nothing but you can refer to a parent CAD geometries and all. And this is exit. This is about a file menu. Now there is something called as edit menu. Title means you can change the title of your project, or you can put a title on all the images. File is nothing but it will open the file into one editor where you can change some things, like generally used for changing the parameters in journal file. So you can do that. Parameter is nothing but this is generally used for parametric modeling. It means if I have a cylinder, I can define that my cylinder is parameterized by using the radius of the cylinder and the length of the cylinder. So I can change in runtime, I can change the radius and the length, and I can create different cylinders with different size. So that is nothing but a parametric modeling. We'll have a look at it later. This is just the introduction to the GUI of Gambit. This is nothing but default, which I was talking about, which are very strong. So there are different type of defaults. There are graphics defaults, file input output defaults, there is a meshing defaults, there is global default, there is a label default and all. So these are nothing but defaults. And this is undo and redo, which are also accessible. If you see here, global control toolpad, there are undo and redo. So this is about edit. Solver is nothing but if you are aware of for which type of solver you want to create a mesh, these type of solvers are supported in fact in Gambit. So if you are interested, if you are aware of which type of solver that you are going to use for solution, then you can select the solver here. So most of the time I guess we will be interested in Fluent 5.6 or something, or maybe ANSYS, or I don't know, Flow Wizard or something. So here you have to select the solver. The solver selection will actually restrict the type of the meshing schemes which are available, some operations in fact. For example, if I go to meshing and if I go to volume mesh, if you see, you can actually create different type of hexahedras, like you can create 8 noded hexahedra, 20 noded hexahedra, 27 noded hexahedra. So if I select for example Fluent 5.6, which is a CFD, finite volume solver. In that we will not look for 20 noded hexaedra or 27 noded hexaedra. Generally these are called as higher order elements. They are used for finite element methods, and in Fluent generally finite volume method is used. So what it will do is, if you have selected Fluent solver, then it will restrict you to create those kind of volumes, and another case is it will also restrict you to export those kind of mesh, because anyway Fluent is not going to understand 20 noded hexaedra. So that is what the effect of the selecting solver is. So this is what I was talking about, the file menu, in which you can open the new file, or you can open a new session or open existing session. And this is import export facilities which are there in Gambit. Then this is the edit menu facility which is there in Gambit, where you can define some parameters or change some defaults and do undo redo operations. This is the solver menu, where you have to select the different solvers. And these are the other components of the GUI, which are nothing but a transcript window, the description window, and the command line, which are nothing but, this is the transcript window, this is the command prompt where I can type the command, and this is the description, and this is the description window. So the transcript window, I guess you can expand the transcript window in two ways. If you click on this second gray line and if you drag, you can expand the transcript window. Similarly, you can expand this view also, because sometimes some things are not visible, so you can expand this view in this way also, and you can type the command. Or for transcript window, you can click on this arrow, it will display the transcript window, and again if you click on this arrow, it will again it will go to the original position or the size. Fine. So this is about the other components which are there. This is something like the control element, GUI control elements. There are something called as command button, option button, radio button, checkboxes, and all. I mean, you will come across these kind of things regularly if you are using Gambit. Then there is something called as list box, text window, pick list form. I will tell you, we'll explore the GUI later. Query list or slider bar which are there, and command buttons and all. So let's have a look at the other components of the GUI, which are a global control toolpad or operation toolpad. So as I said, this is the global control toolpad. This is the global control toolpad. So there are geometry buttons, there are meshing buttons, and there is a boundary condition button. So if you go to geometry button, now there is a vertex button, there is edge button, there is a face button, and volume button. If you have a look at the button itself, if you see, there is only one point, so it is something to do with the vertices. There is a edge, it means something to do with the edge. There is a face, it means it is something to do with the face, and it is something to do with the volume. Now if I click on the vertices, now it will open again one more toolpad which will talk about all the operations on the vertices. For example, the first button is create vertices. So there are different ways by which you can create the vertices, which we will talk about it in geometry build, how we can build the geometry in Gambit. In that lecture we'll talk about it. So this is create vertices, slide virtual vertex, then connect reconnect operation, change the color and all, move copy operations, then create non-real to convert non-real to real vertices, because there are two type of geometries in Gambit. Then summarize the vertices and delete the vertices. Now if you see, typically in Gambit GUI, if you see the button which is something like this, and if there is a downward triangle or downward arrow on any button, it means there are some hidden options available. It means right now you can create a vertex by giving coordinates, but there are other options also for creating vertices. So if you want to see other options, you have to right click on that. If I right click on that, it will open other options which are there. For example, you can create vertex on an edge or on a face or on a volume or at intersection of two edges and all. So if I want to use the option of creating vertices at the intersection, I will click here. Then that particular form will be opened, which will ask me two edges, and it will create the vertices at the intersection of the two edges. So the point is, like, whenever you see a button where there is a downward arrow, it means there are some hidden options available. For example, in this case also there are some hidden options, because I see there is a downward arrow. So if I right click on that, then it will open all the other options which are there. So summarize, check, query and total. So similarly, if you go here, there is something called as undo, and there is one hidden option which is nothing but redo. So this is the redo option. So if you want to open the hidden options, in a case where there is a downward arrow, there will be hidden options. So you can right click on that and you can have a look at the hidden options. So this is one thing that is there. Similarly, if you go to global control toolpad, as I said, global control toolpad controls the way the geometry is displayed in the graphics window. Now we have seen that the graphics window is divided into 4 quadrants, which are something like this. If I want to activate 4 quadrants, I will go here, 4 quadrants. This activate will control which quadrant will be active. Right now everything is red, it means all the quadrants are active. So I will deactivate, let's say 3 quadrants, only upper left quadrant is active. It means I cannot do anything. If I want to rotate or something, that is not applicable. Here only I can rotate the model. So that is nothing but activating the quadrants. So if I say all, it means in all the quadrants I can do some operations. But if you see in all the quadrants, it means that for example, if you split the geometry, this geometry will be also splitted. It is only the view that you are controlling, not the geometrical operations. It means all other quadrants also displays the same geometry. So whatever the geometrical operations that you do, or maybe meshing operations that you will do, that will be also applicable for these views. But only thing is, these views are not active. That is nothing but you can control the quadrant views. As I said, global control toolpad is nothing to do with the geometry and the operations on the geometry. Everything is in operation toolpad. So global control toolpad only controls the way it is going to be viewed. Fine. So let's have a look at the global control toolpad, because it's a general. We need not to have an idea of geometry before this, because we have to we are just controlling how the things are visible in the graphics window. Fine. So the first button, if you see, that is nothing but fit to screen or fit to window. It is also called as fit to window. It means if I do something like this, if my model is somewhere here, if I click on this button, it will be in a current orientation, it will be fitted in the graphics window. So this is nothing but fit to window. It is a standard, you can say, function that is also available in other CAD softwares also. This is nothing but the second button is nothing but the rotate, pivot for rotate. In fact, right now if I rotate the geometry, it is rotated about the centroid of this particular geometry. But if I click on this, now wherever I am clicking, that will be actually the centroid for rotation. So again, if I click, the center will be activated, the centroid will be activated, the orientation or rotation will be done about the centroid. If I again click on this, the orientation or the rotation will be done where I am clicking. So this is nothing but pivot for rotation. Now these are some default views available, in the sense like 4 window. If you have a look at it, it's like Y view, perpendicular to Y, perpendicular to Z and perpendicular to X, and isometric. So if I click on this, by default all the 4 views will be shown to me. So this is like perpendicular to Y, perpendicular to Z, perpendicular to X, and this is isometric. So there are default views available. Again, there, if you see, there is a downward arrow. So if I right click, different views will be there. So if I click on this, there will be 4, means 4 quadrant will be displayed, and again the isometric view of the model will be displayed in the 4 quadrant. For example, if I click here, only upper left will be active and isometric view, or maybe another view. So these are the default configurations which are available. This is nothing but the way the lighting will be there. If I shade this, you can imagine that the shading is nothing but I am throwing particular color light on this model from a particular distance. So you can always control which lights are on and which lights are off. For example, right now if you see, black light is on, white light is on, and again this cyan color or whatever, this is also on. So what I can do, again I can activate this red color, right? So you can imagine, okay, I will say on. Again a blue color light is also on, or maybe a yellow color light is also on. So I can always do that. You imagine that your model is kept in a sphere, and at different location of the spheres, the different color lights are thrown on the model. So you can always control the way the model will be rendered or shaded. So this is not a very strong functionality. Generally I don't know if we are going to use it, but it's there. So what you can do is you can also control from where the light will be thrown, the location of the bulb in fact. So if you click on particular bulb and if you drag, the orientation on the globe can be changed, right? So this is the way the lights will be thrown from the distance. Now there is something called as ambient and distance. It means what is the location of your bulb, how far that bulb is from your particular model. So distance is nothing but it is too far, and ambient is nothing but it is close to the model, something like that. So reset will take you to the default, which is a very, you can say, a strong function, because if you do something wrong you really don't know what you have done wrong. So reset will take you to a default thing. So this is nothing but the changing color or shaded form of your model. If you right click on this, there is something called as annotations. Annotation is nothing but if you again want to print it, then you can add some annotations, like I can add an arrow of red color, the width of that is 1, and then I can add an arrow which is something like this, and which will tell me that okay, this is the inlet. This is not geometrical entity, this is just some annotations that you have added, so that if you take a print graphics, this arrow will be there which will display that which one is inlet, which one is outlet and all. So you can add a different type of annotations like arrow, line, and you can also add a text. Let's say this is inlet, and if I say this is inlet of size, let's say 7, so I can always add this as an inlet, something like that. So these annotations will be useful if you want to use a print graphics function of Gambit, but generally I don't prefer this. What I do is I take the image, I'll put it in a PPT, and then there I'll apply some boundary conditions as per my requirement. So I can also delete all the annotations. If you go to delete all, everything will be deleted. So this is nothing but annotation. The third button which is there, which is nothing but label. So label is nothing but there is display attribute button which is here, which I will explain later. Now whenever in display attribute, if you are going to activate the label, it means if you want to see the label of the entities, what kind of labels will be displayed. So there are regular labels like the face name and all, vertices name, age name, or their you can say the regular labels basically, or boundary layer label. But if I want to say display which type of meshing scheme is applicable for that face, I will activate scheme. What type of what is the interval size which is used for meshing, what is the what is the label of the boundary layer, what is the sizing function, boundary type, boundary condition type, continuum type. I will activate that. I will say apply, and then in display attribute I can say activate the labels. So I will say activate label, apply. If you see, all the labels are displayed somewhere here. So what type of labels will be displayed is based on what type of labels are activated here. So right now I have activated all, but now I will say regular, apply. If you see, only regular labels are, which are nothing but the labels of the entity which will be active. So this is nothing but the label. What type of labels? It means if you want to have a look at what type of boundary condition you have applied, with what interval size you have meshed particular entity and all, so you can choose the particular type of label here and you can activate that. Fine. So the next button is undo redo. If I want to undo some operations which I feel which are wrong, then what I can do is I will say undo and redo. Now by default in Gambit there are 10 undo and redos which are possible. It means recently 10 tasks you can undo, or recently 10 undo you can redo. But you can always change that. It means that if you are aware of that I might make lot of mistakes, and if I want to change let's say I want to have 100 undo redos, you can always do that. There is one default. If you go to defaults and if you go to global default and if you say undo, now if I change it to 100, I can always do it. I can change it to 100. I will say modify. Now hence after, if I am going to do 100 wrong operations, I can always revert back to the original model. But these are quite like, because all the undo redo operations somewhere you have to it has to store it in a registry. So this will be a you can see it will take a lot of memory and all, so computationally they are expensive. So you have to make sure that the undo operations that you are going to put and the memory that you have is quite okay. So the point is, like, you can always change the number of undos and redos that you want to do, but you have to do it before starting any operation in Gambit. Then and then only those many undo and redos are available. Fine. So this is undo redo operation. This button is nothing but the orientation of the model. So right now I can have a look at the isometric view, because if you see, there is isometric view. So again, if I see, there is one downward arrow. So if I right click on that, these are the different views that you can see. So there is a positive X view, negative X view, positive Y view and all. So these are nothing but, if you want to have orientations, or if you want to orient your model in a graphics window in a particular way, then you can always do that by using these buttons. Fine. So this is the display attribute, as I said, which is a very strong tool again in Gambit, which will allow you to have a look at only particular type of entities. It means you can have a look at only edges, and you can make faces and volumes invisible, or you can have a look at only a particular face and a mesh on that particular face, so that if the face meshing is problematic, or if the quality is not good, you can actually examine only a single face and a mesh on that, so that you can define your own strategies for the meshing that face. So this is nothing but a display attribute. For example, let's say I want to make all volumes off. What I'll do, I'll say all volumes, and I'll say visibility off. So all the volumes are moved from the graphics window. Now if I want to have only look at the faces, I'll say all the faces should be on. I'll say apply, so all the faces are on. Or if I want to have a look at only vertices, again I will say all faces off, and all vertices should be on. So if you see, I will have a look at only the vertices. So this is nothing but, you can control the view of a particular entities in a graphics window through these display attributes. Fine. I guess down the line we'll have a look at it when we'll see some do some tutorials and all. Fine. So this is nothing but display attribute. This is the three views that you can have a look at. One is wireframe, other is shaded, and the third is hidden. It is also hidden here. So now let me activate the volume, on, apply. Now I can have a look at the wireframe, I can have a look at the shaded form of it, or I can have a look at the hidden. It means hidden line. I mean, hidden lines will not be displayed, only the front portion of the thing will be displayed. So this is nothing but the three views that you can have. Fine. This is again a very strong tool in Gambit, which is nothing but coloring entities. It means whatever the geometry which is there in Gambit, they have assigned some color to that. It means if there is a volume, then that volume edges will be displayed in green color. If there is only a faces, then that face will be displayed in I guess a cyan color. Let's have a look at it. Volume off, all volumes off, all faces on. Yeah, it is cyan color, and the edges will be displayed in yellow color. Fine. I mean, we'll talk about it later, like when we'll see the entity coloring and cleanup operations. Generally they are useful in this. So this is nothing but color by entity and color by connectivity. So these are the two things which are there in Gambit. Fine. So the last button which is there, that is nothing but examine mesh. It means if you have created a mesh in Gambit, you can actually examine that mesh for as per your criteria. It means, let's say I create the volume mesh in this particular volume. Definitely I can create all hexahedral. It looks very simple volume. Now I can actually examine this mesh by using this button. Let's say I will click on this, and then I will say, okay, I want to have a plane cut, and I want to look for a hexahedral element. So I will say update. If you see, you can have a look at the hexahedral elements. If I slide this bar at different sections, it will show me what is the type of mesh which is created. Or I can take a section which is perpendicular to Y, or I can take a section which is perpendicular to X. So there is something called as a plane cutting plane, or spherical cutting plane, or you can also have a look at the elements in a particular range. In the range, in the sense the worst to the best element in the volume. So you can have a look at it. We'll talk about this once we'll see the meshing operations in Gambit. So the last button which is there, that is nothing but the examine mesh form. So this is the examine mesh form. So as I said, the downward arrow, you have to have a look at other options also, which you can do always. Then these are some of the operations or some type of buttons which are there. So they are quite obvious, and the meaning of them is quite obvious. So it means if I go here, if you see, there is something called a square triangle or something like a square triangle here. It means again there are hidden buttons. It means I can create hex type of element as well as combination of hex and wedge and text. So whenever you see this kind of button in Gambit or this kind of symbol in Gambit, it means again there are some hidden buttons available. So that is the one thing that you have to notice. This is like a checkbox. If I activate or I can activate or deactivate this. This is like again a checkbox. And if you go to examine mesh form, there is something called as a slider bar. This is like a slider bar. So these are the components of Gambit GUI. There are different type of coordinate systems. There are cylindrical coordinate system, spherical coordinate system, and all. There are something called as radio buttons. I mean, it's quite understood. I mean, they are not difficult to understand. Check boxes are there. Text boxes. Text boxes are nothing but where you have to put some text. You have to put some text. That is nothing but the text box. For example, if I create, for example, if I want to create, this is nothing but the text box. It means I can give the label to the entity. This is called as text box. So that is the text box. Fine. This is a list box. This list box is nothing but you have to select the entities. For example, you can do a selection of entities in two ways, which I will talk about it. One is like for example, let's say I want to volume or age, let's say I will use one command, reset mesh, which will delete everything, like everything in the sense all the meshing part. Now let's say I want to mesh the age, only one particular age. What I can do, I can click on this, it will open a pick list form, and I can select this age. I can drag it somewhere here, and then I can specify, okay, I want to have, let's say let's say I want to have 20 elements on that. I can say apply. This is nothing but the pick list form. This is typically called as a pick list form. It is quite obvious. You select the entities, all the entities somewhere, something like this. You click on this arrow, it will be picked, and then you specify whatever you want to do. Or you can say all things will be picked, or you can say deselect all, something like that. So this is nothing but a typical pick list form, but generally I don't use this. What I do is I go into something called as a pick mode, which I will explain you later, and then I will select the entities, and then I will say apply. So that is generally I prefer, which will make you a very strong user of Gambit. Fine. So this is what the pick list form is, and I will introduce you the pick mode of Gambit. So only thing is I explained you what is the pick list form and all. Fine. This is the typical pick list form, where you have to select the entities, click on the arrow, it will be selected, and then you can do some operations on those selected entities, or you can deselect all, you can select all, or you can deselect the selected entities, particular entity in fact. So this is the summary of the typical form. If you see, this is the list, pick list, where you have to select some entities. This is the radio button, which you can activate or deactivate. These are again the radio buttons. This is like a checkbox. This is the command button. This is like option form. If you see, there is some small, you can say a square here. It means there is again some options available. This is the text box entries. Like in this case, you have to provide the numerical values, so that this is the move copy form. So this is nothing but a typical form. Fine. Now this is the summary of you can say this is the summary of the text box and the list box. This is all about the GUI of Gambit. There is only one thing that we need to discuss, like what is the mouse operations in Gambit. Like it's a standard operation as you see in other CAD softwares. Like the left click and drag is rotate, the middle click and drag is nothing but pan, and the right click and drag is nothing but zoom in, zoom out. It can also do a rotate operation if you drag it in a particular way. There is another mode which I said, which is nothing but the pick mode. If you want to select some entities, you can go into pick mode. For example, let's say I want to mesh this particular edge. So what I'll do is I can do that selection somewhere in the pick list form. I can always do that selection, but the best way of doing it is first is go into pick mode. So how to do that is right click and then keep on pressing it, and then left click, you will go to a pick mode. Arrow will be converted into this kind of thing. Your mouse will be converted into this kind of symbol, and now you can pick, and then you can say either apply here, or maybe you can say right click. So that is nothing but apply. Now this is also pick mode. If I want to select another entity, for example, if I want to go for a face mesh, and now basically you have to click on the boundaries for selecting particular faces. So if you click on this face, let's say I don't want to select this face, but I want to select this face, but if you see the boundary here is common. So what I'll do is I'll do a middle click for next selection. So I'll do a middle click for next selection. So middle click is a next selection if you go into pick mode, and then right click is apply. So this is nothing but the pick mode. If you want to go again back into a back mode, so this is about the pick mode. There is one more thing that let's say I want to select all the edges which are coming in this range. For example, if I want to select the edges which are something like this, again I can go into pick mode and I can select this in this way from top to bottom. If I drag, we see the remaining edges are also selected. Can you see this? These are the edges also which are selected, but this is nothing but wherever that box is touching, those edges will be selected. Wherever that box is touching, those edges will be selected. But now if I want to select particular edges, I'll just delete the mesh. If I want to select particular edges, then what I can do is I can actually do this. I will do from bottom to top drag, then whatever the entities which are coming in that particular box or completely enclosed entities will be selected. So you can say apply. So this is the selection operation. So you see, this is what I was talking about, the pick mode, bottom to top drag and top to bottom drag. That is what the mouse button is, and this is the typical you can say the functions, like action is drag, left click XY rotation, middle click translation, and right click zoom or rotate. This is pick mode. Left click is pick, middle click is next, and the right click is accept. So this is what the mouse operation is. We'll talk about all other, like we'll explore geometry capabilities as well as meshing capabilities in Gambit in lectures. So this is all about the GUI of Gambit. Thanks.